if we expand upon what we looked at yesterday, we spent a lot of time on the left-hand column. I mean, not a lot, but this is where the majority of time was spent, okay? So what is everything that you can tell me about an alkane with the brief amount of time that we can? Can be. Most important aspect is they are single bonded, okay? So if you say that they're single bonded, you're not wrong. This would be an example of a compound. You would not know that by looking at it, but yes, it is a gas if it's not under pressure, and it is propane. And what type of formula is this? In other words, how is that different from what we see on the right? We perhaps didn't write it down, but one of these is a molecular formula, another one is a structural formula. But which one's which? Okay, so then that's correct. This is a structural formula. This is a molecular one. And once we get up to this compound, okay, what is everything you can tell me about that besides it's an alkane because it's in that column, and it's also single bonded. And when you say pentane, why is that correct? Because then you're looking at the geometrical shape. Okay, and that remains true all the way up to this one. So you don't have to be too concerned about the 22, but you're just looking at the 10. Okay, say that again. Close. And it maybe in some periodicals it might say dentane, but that's not correct. You're, like I said, you're really, really close. It's not N and T there. Say that again? No. Okay. So, which is probably derived from, I'm sure, Latin, because of how many years makes up 10 years. What's that called? Decade. Yeah, it's called a decade, and that's probably where this is derived from. Okay. We'll come back to these in just a moment. Okay. So, in this case, pick a number between 4 and 8. Okay. I don't know how well that's going to show up on there. Maybe we're better off using just this type of a marker because it is so bright in here. So we heard 5. So since we're putting under this column, you have to illustrate there has to be one specific aspect in this parent compound as opposed to this one. Okay? So then, just to keep this as simple as possible, okay? And the rest of these are single bonded. What about this one here? Okay, why is it only 1? Because it has a double bond there, and that's why this one only has 2 hydrogens instead of 3. Okay, because again, to be saturated, or excuse me, not saturated, but for all this to become stable, carbon has to have 4 bonds. And it does, because it's got 2 hydrogens and 2 bonds to that carbon. That carbon has 2 to this one, 1 to that one, and 1 hydrogen. And then everything would represent the same thing that we see here. Okay? So typically we read left to right, which I think everyone would agree that we do that. But if you can remember when it comes to naming compounds, well, organic compounds, you want to associate or assign the lowest possible number for anything that's either branching off of that or multiple bonds. So if that's the case, would we be looking at which one of those names would be correct? The top one or the bottom one?
The top one.
Okay, we hear the top one.
It's the bottom one.
Now we hear the bottom one.
It's the bottom one. Hear the bottom one.
Okay. And this is maybe a low down dirty trick, because if you really wanted to be specific, you could do that. Because we said typically you read left to right. So when we do that, we would think, okay, after our fourth carbon, there's a double bond. But we can also read right to left. So therefore, that double bond is after the first carbon. But when you are only utilizing the number 1, you don't have to assign that number. You can, but there are circumstances where you would have to put this number on here, but that's more so of an application. It might occur in general chemistry, but it would be more of an application for the organic chemistry class that's offered next year. Okay, and you might be asking yourself, well, why don't we have to put that 1? Okay, and a lot of examples we like to use is sulfuric acid. What is the formula for sulfuric acid? Is that wrong? No, that's not wrong. But why is that 1 not needed for that? Yeah, you'd probably get laughed at, I would agree. But it's just understood, how many sulfur atoms do you have even without this? That's correct. So therefore, what you can presume then is that when you see that structure, that 1 is not needed for the very same reason a 1 is not needed for that sulfur. You're speaking for your classmates. Does that make sense? Okay. Then what do you think you can tell me about the difference between this family of organic compounds as opposed to this one, as opposed to this one? Okay? Now, alkynes are not very common, except for one, and it's probably in this school somewhere.
Propane?
Nope. Say that again. You might think so, but not propine. Nope. And I'm just going to pick on yourself. Because, are you doing welding right now? Okay? So if you want to cut any type of metal, yeah, you could use a welder, but I wouldn't be very good at it. All I know is I think you really want to crank up the voltage or turn it up, and then I think you go at an angle, and that will cut a hole through your metal. But the problem is it leaves drips of, is it slag? I thought, okay, so it leaves drips of slag. So you might have to take a grinder and grind that off. What would be a more efficient way to cut metal rather than a welder? What kind of, well, in a plasma cutter is not incorrect, but in this case, when you say torch, why would that be more applicable? What type of gases are involved?
Oxygen.
That's one. You're starting to say it. Right. So if we're talking about this compound, okay, Now, this is just a spelling. It's in no reference to that family of compounds. We'll explain why you need to be careful when you say that. Because this is the formula for acetylene. Now, would you rather have the hydrogens on the top or the sides?
Sides.
Okay, so that doesn't make any difference. Okay, so there is our formula for acetylene. Everyone would call this acetylene. Okay, and it follows a very similar pattern. What would a 2-carbon compound that's an alkane be called? This is ethane. What is a 2-carbon compound that's an alkene?
Ethene.
Okay, so then what would a 2-carbon compound be that's triple bonded?
Acetylene.
True. Scientific name. Okay? But you're not going to call up, I know there's a supplier on the north side of Sioux Falls. I don't know the name of that gas company. If you give them a call, you're not going to say, we need a shipment of ethine. They probably would say, do you mean acetylene? Sorry?
Have you tried it?
No. I'm just making a intuitive leap to say that that's probably pretty accurate. They probably think, they don't trust you with a torch, do they? No, they might not say that. I don't know. But these mean the exact same thing. Okay? This is typically probably, we don't get too much involved into the alkynes just because they're really not very common, except for that one. Very important alkyne. Okay? Now, we said that we would come back to these, and what that means is, okay, this compound or this one?
This one.
Left or right?
Right.
Okay? So we heard the right one first. So we know that this is incorrect, so we can erase that. Okay? So then, what is the formula for this alkene here? How many carbons does it have? Okay? So here is its formula. And it's an alkene. So what would happen if we just rewrote that and named that compound? What would we have?
The same thing.
Why is it the same thing? That's right. Yeah, because that double bond is still after that first carbon, just like this one. Okay? But if we switch this to perhaps this, then we'll erase that one. Okay? Do we still have pentene? Yes.
Got 2 pentene and 3 pentene.
Okay? So then, therefore, this is where we're going to pick this instead of the number 3. Why is that? Because you picked the lowest number.
Would it still be wrong?
Yeah. Okay? That's just like, for instance, if you're playing a par 3, you'd rather have a 3 on there rather than a birdie at 2, right? Right?
No, I had birdie.
Well, that's what we just said.
That'd be 4 though.
How? How's that 4?
On a par 3? A birdie?
That would be a bogey then.
Oh, I didn't think.
Okay? You had the right idea, just wrong direction. Yeah. Bogey is just 1 over par. Yeah. Okay? So then, if we're really good, if we move it to the right one more, does that make it an eagle then?
Yep.
No. It'd still be 2 pentene. That's right.
Would it be
Yes, it would be wrong. Okay, so what's true about these two compounds?
The same.
Got the same molecular formula, don't they?
No. Oh, yeah, molecular. Yep.
Yeah, because we established these are molecular formulas. Do they have the same structure?
Nope.
No, they do not. So at the really basic definition of a type of compound, or compounds in this case, that has the same or identical molecular formula, but the structures are different. Those are called isomers of one another. Okay? So, we've talked about the alkynes, we've talked about the alkenes, and then we even introduced the alkanes. So, let's try to, we can get rid of, we'll leave that one up there since we're dealing with 5 carbon compounds, in this case 3 carbons. Let's draw an isomer like we did of these 2 compounds for propane. I want you to work on that for, I'll give you 10 seconds.
I gotta draw my head.
Tick tock, tick tock, tick tock, tick tock, 7, tick tock, 8, tick tock, 9, tick tock, 10. You should be done by now. You know why? Why should you be done with that by now? Because it does not have one. That was a low down dirty trick, wasn't it? Yeah. Yeah. You have to have 4 carbons or more to have an isomer for this. So therefore, we'll go all the way down here to pentane, which means C5. So with our very limited amount of time we spent with this, how can we make an isomer of C5H12? Okay, the most simplest thing to do is take a carbon off of the end, okay? You might say, move it over 1. So that's what we will do. We took it off of the end and we moved it over 1. So now we've got our isomer of pentane. Or do we?
No.
Why not? You're saying no, that's correct, but that doesn't explain why not.
Got to erase another one.
Oh, okay. We had the right idea, we just did not apply it correctly.
Put it up top.
You have to move it over more than one.
Exactly.
It's still on
This is still pentane. This is still part of the parent chain. Okay? So when you say take this carbon off and move it over 1, which would be correct, our longest continuous chain is now called butane. And what is a 1 carbon derivative? Do we remember what that is from 2 years ago? It is a methyl group. So 2-methyl butane. So last thing we'll mention, you can reverse engineer each and every one of these, which means this is your organic family. Okay? So ANE means what within the compound? The entire compound. The carbons are what?
Single bonded.
Single bonded. This is your organic family. So it is making a reference to what inside of the organic or the carbon compound?
Double bond.
Double bonds. And then what can you presume about this? Okay? Now, if we reverse engineer this, this is telling you that you have an alkene that somewhere there's a double bond. This is telling you something specific as well. What might PENT telling you?
5.
That is telling you your parent chain. Then what is that 2 making reference to?
Where the double bond is.
It's telling you where the bond is. Okay? One of the things that's very crucial or important for applying organic chemistry is that if there is not a if there's not a term after a number, it tells you one of two things. One, either where a bond is or where the organic family is located. That's for another time and same place, but just for another time. We will pick up with this content again on Tuesday, and I hope that those of us are gone, please keep up with this because there's a great chance that you will not be here on Tuesday, April 2nd. We discussed that you either possibly be in Flandreau, but not likely. More likely, Gesundheit, you'll be down at Elk Point, Jefferson, EPJ. And then Wednesday, you're taking your Smarter Balance test during this class time. And then Thursday, that remains to be seen. Yeah, that's beyond our control, being a week out. Okay, so you've got to stay on top of this. This is probably, I think it would be difficult not being in the classroom and having the opportunity to hear this in real time, but this is the best that we can do for that. Okay, so that's all I have. We'll catch up to you next time, and enjoy Peter Cottontail. Oh, not rabbit. Is it lamb? Ham?
No, it's bunny.
Chicken?
Bunny.
Okay, yeah. So chop up old Peter Cottontail and throw him in the oven.
No, that's a rabbit.
That's probably not very nice. Yeah.
That's a rabbit.
Enjoy your Easter meal. Catch up to you next time.